The minimum number of socks I must take out of the drawer. This is a classic logical puzzle. 24 red socks and 24 blue socks are lying in a drawer in a dark room. What is the minimum number of socks Winston must take out of the drawer, which will guarantee that he has at least 2 socks of the same color? Now, the answer to this is 3. But the point of providing a solution is not merely to get the factually correct answer, but to justify that answer. That's what is characteristic of it as a logic puzzle, is that you need to demonstrate an understanding of the logic of the puzzle in your solution. So it needs to be justified. And that's where often we run into difficulties. Okay, so the elegant solution is this. Winston must select 3 socks. First, he will grab 2 socks. It might be that they are the same color, and Winston is good. And grabbing a 3rd sock won't disturb the original matching pair. But suppose the original pair is mismatched, and there is 1 sock of each color. Winston then grabs a 3rd sock. This 3rd sock certainly is either blue or red, because that's the only kind of socks that are in the drawer. And regardless of whether it's blue or red, it will match one of the original 2 mismatching socks. All right, so that's the elegant solution. This is something of a common sense solution, and it is elegant because it gets directly at the logic of the problem and justifies the answer of 3 in a very direct manner. Now, there is a more complicated explanation that I would like to go into. The complicated explanation thinks of the picking of the socks in sequence. So we're going to pick the first sock, the second sock, and then the 3rd sock, and see what configurations are possible. So we're going to look at all possible cases. So when Winston picks the first sock, it's either red or blue. That's the first pick. Then he will select a 2nd sock. So if the first sock was red, the 2nd sock might be red, or it might be blue. Looking at this upper branch, if on 2 picks he has 2 red socks, then he has a matching pair, and the condition of finding a matching pair has been reached. However, if we look at this lower part of this upper branch, we see that it's possible with picking 2 socks, he could get a mismatch pair. And the same thing similarly applies if the first sock is blue, then the second sock is either red or blue. In the middle branches here, we see that we get mismatched pairs, and in the outer branches, we see that we get matching pairs. So there's 4 possibilities here. This is after the 2nd pick. And the crucial part to the puzzle is these middle branches where there are mismatching pairs. That's what requires the 3rd sock to be picked out. And when we continue the logic out, we get now 8 branches. So it doubles. And we see at this very uppermost branch, we get 3 reds, that's fine. There's a matching pair in there. And in the second branch, we see that we still have those matching reds, even though we have a mismatched blue, but that doesn't matter. And then the crucial part is in these middle branches where first sock is red, second sock is blue. Well, we're either going to get a red or a blue for the third pick. And so if the third pick is red, it matches the first. If the third is blue, it matches the second in this branching here. And similarly, if the third sock is red, but the second one was red, then we get a match. And if the third sock is blue, but the first one was blue, then we still get a match. Okay. And of course, in the bottom here, we already have 2 blue matching, so it doesn't matter what the third is. So the third sock, picking the third sock, guarantees that Winston has a matching pair, because there's those middle branches that require that third sock to be picked out. All right, and then we get all these possibilities of configurations of red and blue socks. And this really does cover all possibilities, all possible configurations of socks when we think of it as selecting the first, second, and third sock. And we see which, with each of these possibilities, there is a matching pair. Okay. I went into this more complicated explanation because there's a good analogy, or really more than an analogy. There's an isomorphism with this sort of branching logic and the way that we set up truth tables. So there's a relationship to truth tables here that I want to bring out. And so instead of thinking of picking the first, second, and third sock, we're going to think of variables, and we're going to think of truth values. So the first variable that we have in a symbolic expression, that can be either true or false. We can give it the interpretation of being true or the interpretation of being false. And of course, the first variable we will refer to as A. And then if we're on the interpretation that A is true, then the second variable could be either true or false. And likewise, if we're working on the interpretation that A is false, then the second variable, B, can be either true or false. And then we get 4 possibilities here, 4 possible configurations of truth values. A and B being true, 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 false, false, true, or false, false. And we've seen this in our lookup table in the earlier chapters that we've been working on. Our lookup table has these 4 possible configurations of truth values for the left and the right variable, being 2. Okay. Now, when we add a third variable, the possibilities double to 8. So we carry out this branching. And of course, the third variable is C. And then we get all these possible configurations